Hello DevOps Summit Canada. My name is Chris Lloyd-Jones and I'm here from Avanade to talk about greening our code. So before I dive into greening our code and what that is and what that means, here's a little bit more about me. So I'm the head of open technologies at Avanade. Open technologies for me means open source software, developer relations, and the ecosystem, working with organizations like the Green Software Foundation, which I'll dive into in a little bit more detail. I am also the open source working group chair at the Green Software Foundation. I'm a Microsoft MVP in AI, and within the UK, I am the Chief Blueprints Officer at Open UK, creating sustainability blueprints to help with things like sustainable electric vehicle charging. You can find me on Twitter at CLJ_CLJ or on GitHub as well. So for those of you who haven't heard who Avanade are, we're an organization that for 22 years have been working in the Microsoft ecosystem. And that ecosystem is growing broader with GitHub as part of the family, and we were created as a joint venture between Accenture and Microsoft. So we are 17 times winner of Microsoft Global SI Partner of the Year, and we have 60,000 people growing to 100,000 people over the next couple of years doing Microsoft work every single day, including in offices all over Canada. We have skilled and diverse professionals, 29% of whom who are women, and we have more Microsoft certifications than any other partner. And what we want to do is combine technology, business, and industry expertise to design, build, deploy, manage, and evolve solutions. But enough about Avanade. I am here today to talk about green software, green code, green DevOps, and why you should care. This talk is divided into three parts. I'm going to talk about the what and why of green software. So what is it? Why does it apply to us as developers? Tooling and getting started. So from a DevOps perspective, what is there available to help me to green my software? And then finally, the Green Software Foundation, what are the options for me to get involved? I often like to start these talks by defining what I mean when I use the term sustainability. And obviously, being in this role, I've learned a lot over time. So one of the things I learned early on is that there is a standard definition of sustainability, and that comes from the 1987 United Nations definition, which is meeting the needs of the present without compromising the ability of future generations to meet their own needs. And I like this term because it's very clear about what it means, whereas other terms like eco-friendly, green, and other things, they're not always quite as clear or quite as well defined. So we know what this term means. And when we talk sustainability, organizations are feeling the pressure to operate in a sustainable way. Going green can reduce their cost, it can increase productivity. Regulators, particularly in Europe, which you've probably detected from my accent is where I am, are finding and driving incentives for companies to comply. Consumers are leaving well-known brands and are willing to pay more to sustainability-focused businesses, those who talk about how they're basically making sure that we're all not going to die in a massive heat death one day. And investors are paying close attention to companies' sustainability initiatives when they're considering funding. And I think you can see the trend starting to cross companies around the globe. In Nordic countries, with Finland in particular, there are some very strict procurement rules. In the United States, just south of most of you all listening to this, Biden signed a declaration stating that the federal government must start to procure green services. So more and more this is going to become a thing to do because of regulation, but also because it's the right thing to do if we want to be on a livable, viable planet. Sustainability can come in many forms. Most of my talk today is going to be around carbon and carbon emissions. And when I say carbon, I mean carbon equivalents. There are many other greenhouse gases, as we call them, that are being emitted into the atmosphere, which are causing the overall environment to heat up in some places and leading to drastic climate change in others. And ultimately, when I'm talking about sustainable and green software, I'm talking about software that has a reduced amount of emissions. Now, there are many other ways to reduce emissions. Some organizations talk about offsets. Now, really, I'm not a big fan of offsets because offsets either means that you are avoiding the problem because you still continue to emit carbon and you pay someone else not to emit it, or the most expensive type of offsets actually use technology to take carbon out of the atmosphere. That's very hard and also uses energy. I prefer the option which is abatement and elimination, not emitting carbon in the first place. Obviously, some carbon will always be emitted, but it's ultimately about trying to see if we can make that better and cleaner. Now, you might be there thinking, what does this matter to me? You're talking about sustainability. Well, what gets measured gets managed is the common misattributed phrase to Peter Drucker. And even when it's pointless to measure and manage it, and even if it harms the purpose of the organisation to do so, what gets measured gets managed. And many of the focuses on sustainability, from circular economy to new business models, are actually above the ability of individuals to make a difference. They either focus at the top of an organisation, at the level of governments and nation states, which is important, or at the enterprise level, what can a large multinational do? Even some standards in this space that drill down to parts of a company still don't really have much that we as individuals can do. But in terms of software, there is actually things that we can do that are in our span of control. Now, I'm going to cover what green software is, finally, and green software ultimately is software that has a low carbon intensity. That is a rate of carbon emissions for software that allow us to monitor the impact that small changes can have on the sustainability of our software. That means we need processes to measure and optimize our software. And again, I'll talk about how this all fits together. So you might remember I talked just a slide or so back about greenhouse gases, including carbon, but carbon equivalents. When we're talking greenhouse gases, we tend to talk in terms of scopes. The Greenhouse Gas Protocol defines scopes 1, 2, and 3. Scope 1 is the direct emissions, maybe from the software we use and we write, or the carbon that's in the buildings which we might be sat in, or a home. Scope 2 emissions include indirect emissions from electricity purchases, as well as things like steam, heating, cooling. And Scope 3 emissions are those from downstream and upstream activities. By upstream, think the goods and services that we buy, the capital goods in our offices, operational waste, and our travel. By downstream, think of maybe investments, transportation, distribution, recycling, things at the end of our product life. And when we think of carbon emissions, I know myself, my mind jumped to Scope 1, direct emissions from company-owned and controlled resources. Writing software helps us to reduce these if we write it in a sustainable way, and it also helps us to reduce the electricity consumed in Scope 2 and by the end users of our software in Scope 3. Put bluntly, when software runs, it uses electricity. That electricity had to be generated, and if it is generated from fossil fuels rather than renewables, then it has a carbon impact, which means we need a way to make our software greener. So I mentioned that I am the open source working group chair within the Green Software Foundation. Well, the Green Software Foundation was founded a year and a bit ago now, and the idea is that they exist to create a trusted ecosystem of people, standards, tooling, and best practices for green software. So everything I was talking about before, the different scopes, they're there to help create the standards for how we measure the carbon intensity of software, the tooling to measure your current carbon cleanliness and then reduce it, the community to share information, and policy working groups to inform policymakers. As part of its goal to support green software engineering, the members of the Green Software Foundation have focused on that software carbon intensity standard, a specification to measure the carbon intensity levels of software. And the idea is a usable standard that can help to drive down the carbon emissions of any software application, from a large cloud system to products that utilize open source libraries, any on-premise application, or even serverless function. What it does is it generates a rate, and the idea is that score goes up or down based upon the actions you take and that if you know that you're always lowering that score, your carbon emissions are always improving. It's about ensuring that the score is lower tomorrow than it is today. And to my mind, because it's something that we can see and we know exists, one of the most popular targets that companies are trying to resolve in terms of greenhouse gas reduction is usually hardware or something physical. So generally companies might be overlooking one of the biggest causes of their carbon emissions, their software. And this isn't a small amount of software. One research piece I was reading a while back said that by optimizing your software through hardware awareness, energy efficiency, carbon awareness, you can reduce your emissions by up to 51%. And one of the studies I looked at said that equated to 120,000 metric tons of carbon. And again, to put that into context, that could be the equivalent of keeping 26,000 fossil fuel cars off the road. So by making your software greener, it's almost like we avoided having 26,000 fossil fuel cars on the road in the first place. So the software we're using right does have a massive difference and a massive part to play. So this standard has a set methodology, a methodology for calculating the rate of carbon emissions for a software system. And I mentioned it generates a rate, and that rate has the purpose of helping users and developers make informed decisions about the tools, architectures, and services they're using in the future, whether or not they use software by purchasing it off the shelf, or whether or not they write software, so that you can take an action to make software use less electricity to perform the same function, to make software use fewer physical resources to perform a function, or maybe if you're a cloud compute user, you time or region shift your computation to take advantage of clean, renewable, or low carbon electricity. Now, the Green Software Foundation has also defined 8 principles of green software. And the idea is that by taking these principles and learning the Green Software Foundation patterns and applying the Green Software Foundation practices, we know that we can make software that is greener and more efficient. So I guess the first principle is to build applications that are carbon efficient, because greenhouse gases act as a blanket that increase the Earth's temperature, which is a natural phenomenon. So most common greenhouse gas is carbon, but due to human activities, the global climate is changing much faster than animals and plants can adapt. There are many different greenhouse gases. The most common is carbon dioxide, but we normalize all greenhouse gas numbers to carbon dioxide equivalents to make calculations simpler. So 1 ton of methane has the same warming effect as about 25 tons of CO2. So we normalize it to 25 tons of CO2. We may even just call it carbon, just to refer to all greenhouse gases, as you might have noticed I've been doing. The second principle is that electricity is a proxy for carbon, because most electricity is still generated in fossil fuels. So as engineers, we need to understand electricity better. Now, the third principle is carbon intensity. All electricity has a rating, and the electricity that you are consuming right now to watch this video has a rating. The carbon intensity of electricity is a measure of how much carbon emissions produced per kilowatt hour of electricity have been consumed. The standard unit for carbon intensity is grams of CO2 equivalents per kilowatt hour, or grams of carbon. And carbon intensity is high when you get most of your electricity from fossil fuel plants. So when the wind isn't blowing, the sun isn't shining, it gets worse. And you want to consume electricity with the lowest carbon intensity. The fourth principle of embodied carbon is that devices or servers release carbon in their creation and in their destruction or recycling. So try to extend the lifespan of your device. Devices become obsolete earlier if we're writing inefficient code. So let's see how we can change that. Principle 5 is about energy proportionality. So maximize the energy efficiency of hardware. Hardware tends to have a static power draw. So a server running 50% workload is not the same as a server running at 50% of energy usage. The more you use a server, the more efficient it becomes. So the memory of your graphics card, your CPU, generally the energy consumption is pretty static. It doesn't change regardless of how much you're being used. Now, number 6 is networking. reduce the amount of data and the distance it has to travel over the network. Network is physical hardware. It has a router, switches, servers, Ethernet cables. Number one, they all have embodied carbon. So you think about the local energy mix. You need to think about the data that you send or receive. Everything has a carbon measurement. There's lots of factors, but it's just a really important factor. How much data are you sending? How far is it going? Reduce the amount of data and reduce the distance. Number 7, think about carbon-aware applications. So maybe if you are video conferencing, when the energy grid is clean, you might use more bandwidth and transmit more data, so higher fidelity video. And when the energy grid is dirty, you might send lower quality video. And finally, number 8 wraps it all together. We focus on step-by-step optimization to increase overall carbon efficiency, improve performance, and reduce cost as well on top. So you've heard me talk a lot about sustainability and define a few terms around green software. So now I'm going to start to explain how you can make use of green software. So I'm going to recap the software carbon intensity standard because it's at the core of a lot of the tooling which we are creating at the foundation. So your software carbon intensity is your operational emissions and your embodied emissions per R. R can be any particular functional unit. That might be your rate of carbon per user, per API call, so daily active user, API call, video play, Teams call. That's R. R is just the rate that you stick to and use the same way every single time. E is the energy used by your software, expressed in kilowatt hours. I is the location-based carbon emissions, or grams of carbon emitted per kilowatt hour. So you multiply your energy by the carbon intensity, and then you add, after that, the embodied emissions for your software. So a time slice of the carbon emitted during the creation and disposal of your hardware device. You're not responsible for 100% of the embodied emissions of the device, just the embodied emissions for the amount of time that you're using it. So if your software uses 1% of the server, you're responsible for 1% of the embodied emissions. So effectively, you're trying to add on the amount of carbon the software is emitting, your operational emissions, embodied emissions per functional unit. And that's how you calculate your software carbon intensity. Sounds easy, right? So that's software carbon intensity. And once we know your software carbon intensity, you can write or use software, you can measure the carbon intensity, and then you can take an action. You can reduce the electricity software is using to perform the same function. That's improving energy efficiency or code efficiency. You can reduce the physical resources your software is using. That's hardware efficiency. Maybe you move to the cloud. Maybe you change the hardware that your software is running on. And the third piece is carbon awareness. So you take an action to time or region shift your software to leverage clean or renewable sources of energy. So I'm going to dive into that third principle, carbon awareness, a little bit more. Carbon awareness is about doing more processing when the energy is clean and less when it is dirty. And cleanliness is determined based upon the carbon intensity of the electricity used, as seen in the diagram on the right. The intensity will generally be lower when the electricity comes from renewable sources. So maybe we have more solar or wind energy in the grid. It's maybe an intensity of 100, and with more coal and gas energy, it might increase from like 350 grams of CO2 per kilowatt hour. And the idea is that once we know the carbon intensity, we can look at different times of day and shift our software and when it runs. So maybe at night, the energy grid is slightly cleaner. So if you have batch jobs to train an AI model or process some invoices, you might want to do that at a later date or time. There might also be when you want to start building and deploying your software. You can see where I'm going with this. The other idea is that you might want to apply location shifting. Instead of moving the job in time, we can move the location where the job physically runs, shifting to a different location in the cloud, which is great if you want to run tasks that aren't bound to a particular region. So we know what carbon awareness is, and then we can time or location shift particularly for jobs that are repetitive and it doesn't really matter when they run. So before I come on to some of the tooling to help you do this, here's a couple of practical examples. On the left-hand side, you can see that when I was looking at the energy grid in Australia earlier this year, at 3 a.m., 355 grams of carbon were emitted per kilowatt hour, and at 3 p.m., 529 grams of carbon were emitted per kilowatt hour. So depending on the time of day that a job ran, the grid would be cleaner or not, and therefore we might want to identify when we want to deploy certain things or run certain build tasks. And if we look on the right hand side, we can see that again, and this data was the 19th of January, so it's well out of date now, but you can see that by right sizing cloud infrastructure or on-premise infrastructure even, we can actually reduce cost and we can reduce the spend we have on particular services without compromising our software. So again, as DevOps practitioners, if you're responsible for identifying when software runs to build or where the resources are going in the cloud or on-premise, you have the ability to decide how much of a carbon impact the software in your span of control has. And another action we can take is profiling. We can report on how much time was spent in different areas of the code base. So maybe you want to instrument your code, you profile the software current usage, and you improve inefficient code. So by reducing CPU usage, we reduce electricity consumption, E, which reduces our carbon emissions. Maybe you want to look at dangling references or unused code paths. And here's the meat of the thing, which maybe I should have started on earlier, but I'm showing it to you now because I think the definitions are really important. Ultimately, all of these standards, all of these tools, all of these practices are about trying to get to an end-to-end approach of carbon tracking in every single thing that we do. So this here is an Azure example because I come from a company that focuses on Microsoft technology. It doesn't really matter on your stack, it applies to anyone. The idea is that engineers and data scientists, as they code, can calculate the software carbon intensity in their IDE. As they then commit, a GitHub can calculate the software carbon intensity. We can push our code to GitHub or GitLab or whatever tools you use. And as we generate pull requests, an Azure pipeline or a GitHub action can calculate the amount of grams of carbon emitted per kilowatt hour of energy used for our software. We can compare that to the previous run and see if the new features or bug fixes we've applied increase or decrease carbon intensity. We can then monitor the energy usage in dev, QA, and prod. We can apply custom policies with our cloud provider of choice to limit resources that might be incredibly costly. And then we can use tools like the Emission Impact Dashboard, which is proprietary software from Microsoft, or open source software like the Cloud Carbon Footprint to measure our ongoing carbon, and then we can report on it over time. Now, not everything I showed you on the previous slide is possible today. We don't currently calculate carbon as we code, but one of the things that we can do, and we have created, is a carbon CI pipeline. You can see an example of it here. So every single time a pull request is created, a GitHub action runs, which can generate the pounds of carbon equivalent or the grams of carbon equivalent per kilowatt hour. And we can look at that over 24 hours and over one particular kilowatt hour. And the idea is we can measure the difference over time. This exists. You can go on to the Green Software Foundation. You can try it out, install it in your code base. It's one example of a tool that we are creating to help DevOps practitioners like you to measure the carbon intensity of your software. But the Carbon CI pipeline isn't the only tool. Ultimately, we're trying to get from insights to automation. So we want to obtain carbon insights by connecting to data sources, actually see what's happening as we build, as we run software. We then work with partners like WattTime and others to use AI machine learning models to actually predict the carbon that will be emitted at different times of day in the future and what's happened in the past, so that we can automatically respond to operational carbon impact and reduce the overall footprint of our operations. Another great example for DevOps practitioners is the Carbon Aware Software Development Kit. There's a hackathon ongoing right now the results of which will be announced around November the 10th. And this is a software development kit that you can actually integrate with your code from C# to TypeScript to Python to let your software do more when the grid is clean and less when it's dirty. So as DevOps practitioners, again, you can schedule containers to horizontally scale when the grid is green and downscale when it's dirty. You can change the time of the day when your containers run or when you run deploy tasks. And again, it's a kit which exists today. So you have the pipeline, which can be part of your deployment pipeline, and the SDK, part of the tooling that's running it in operation. The software development kit can be deployed in a number of different ways. There is an API which you can integrate with tools like Kida, for example, which standardizes and simplifies carbon awareness, so you can run an API call. Or you can use the command line interface to get the current emissions data for a specified location, if maybe you want to do some data analysis about the times of day it's best for your software to run. Ultimately, our focus at the Foundation is reduction, not neutralization. 1 gram of carbon emitted into the atmosphere is not the same as 1 gram of carbon that's been offset. What we want to do is make sure that you never emitted the carbon in the first place. Reduction is more challenging for us than offsetting. It needs more risk and more investment, but that's why the Foundation is growing an ecosystem of people, standards, tooling, and best practices to reduce the carbon emissions of software. We're nurturing that ecosystem. And for that, we need all of you who are at this summit, at this event, to spread the word, spread the practices, and get involved at the Foundation. So thank you very much for listening to this talk, and I'll round off by talking about how you can get involved. The Foundation has 4 working groups stewarding tens of projects. One of those is my working group, the open source working group that I chair with Dan Lewis-Tokley. That's creating the tools to make the standards feasible and achievable. There's the standards working group, creating the standards to make software sustainable. There's the community working group, spreading the word through blogs, writing and talks like this one. And there's the policy working group, working with policymakers and the C-suite to identify what needs to happen to make our software sustainable. So I talked about the release of the new Carbon Aware software development kit. I talked about the creation of the Carbon Pipeline project. We've gone from the alpha version of the software carbon intensity specification to the full launch. And I'd also like to invite you to join us on November the 10th to find out more about decarbonised software and the latest advances in green software, including the State of Green Software report that the Foundation will shortly launch. I've been Chris Lloyd-Jones from Avanade from the Green Software Foundation. Thank you for listening to me. You can find me on Twitter at CLJ, that's like my initials, _CLJ, or on GitHub at the same. Thank you very much, everyone.